Hi. So first up the question, who of you develops React apps in multiple teams? Like one React app in multiple teams? Okay, not that many. And who of you even, let's go deeper, and who develops React apps in multiple teams in multiple offices? Okay, so also like third-party developers as well? Alright, that's only one. Okay, yeah. That's a thing we had, we have multiple brands and they have you want to scale this a little bit. So we thought about why not just introduce microservices? And that's what I'm talking about today. So yeah, I'm Simon. I'm a senior software engineer at Delivery Hero. And more specifically, I work at the vendor portal team. And I talk a little bit about our product later. And first, just look at the stuff that we want to talk about today. So first about the problem, what made us decide about choosing microservices, micro frontends. Then about the requirements that we wanted to have for this system. Then the heart of it, the technical implementation, and the limitations and the possible improvements of them afterwards. So first, what are we doing and why did we need this plugin system? So what we built is the vendor portal, which is a tool for restaurant owners to do all sorts of things. They can look at the statistics, think about Google Analytics for restaurant owners, like revenue and orders over time. Self-service, like changing opening times, changing menu, and chain management for the bigger chains like McDonald's, Burger King, Subway, etc., that they can manage their entities in one environment that they don't need to log in, log out all the time. And on top of that, we have different brands worldwide. One of these are the brands we have, for example. These are just some. This is Pizza Online Pizza in Sweden. The problem is, in Finland, we have Pizza Online. It's always a confusion. Here, this is Yu-Gi-Oh! In Korea. This is Foodpanda, which operates in multiple countries in Southeast Asia and Eastern Europe. Pedidos is operating in Latin America. And then we have Carriage and Talabat, which operate in the Middle East. Anyone abroad that used one of these platforms? Oh, some. Okay, so you might be familiar. So, like I said, we have all these brands. And each brand had their own portal, or still has their own portal at some sort. And that creates a problem because we have multiple brands doing multiple portals and basically building the same features and everything over and over again, which takes effort and time, which you could reduce by just having one that is customizable to the needs of these brands. So there are things that overlap a lot. It's like opening times. Everyone needs opening times. Everyone needs statistics and a dashboard, etc. So we could solve this by just having one and then scale it by having the separate teams that operate worldwide contribute to this. Yeah, we wanted to do this with micro front ends, and they should be independently deployable. That was the hypothesis, and we tried it out. So what were our requirements for this? So we wanted to be framework independent, although we wanted to have React as a first-class citizen. We still didn't there are some teams that never worked with React and maybe are familiar with Angular, so we still wanted to be open to this, but we didn't encourage them. So we don't. I mean, it adds a lot of footprint to your app. So every time you go to this plugin, it needs to load Angular, and that's why we didn't give them just a one-pointer hooking, whatever they like. But we said, hey, here's this red thing. When you want to put in Angular, you need to figure it out yourself. So the plugins need to be loaded when a certain route is hit. Let's say we have the reporting plugin. Then you go to /reporting, and then this plugin should be loaded. The plugins, they need information of the restaurant, otherwise they can just render something, but not really do something in context, like what's the current restaurant of the owner, and then take the restaurant ID to do API calls. Then the backends, they are independent of this plugin system, so maybe there's also backends that already exist and they need to be called, and that's why we need to give these backends a way to authorize and authenticate these the users, that they can't do anything on things they are not allowed to. And last but not least is it should be independently deployable, so we can, like, without us being in the way, they can deploy on their own stack and just tell us, so we know, and can update this stuff. So let's jump into implementation. So what we did was we created this plugin endpoint, which is just a normal REST endpoint, and the portal calls this with all the platforms it has. So we give out, like, for this specific platform, can give this specific plugins. So they have like different plugins. The plugins are basically customizable to each platform. So you have one platform that maybe needs their specific things, like their own opening times plugin, and but the rest is still the generic ones, like statistics, they can reuse. And that's why we need to do this call, and what we get out is this array of objects, and you have the bundle URL, which is the JavaScript plugin file, the code that we can identify what plugin this is, an icon to show it in a menu, some options for like customization, a route that we can, because this is like dynamically configured, it's not tied to the bundle, and rules and types that you can, for example, have multiple kind of plugins. This one is a menu plugin, this means it shows up in the menu. And what the portal does is then the frame, it just renders this menu, and you click on it, and you go to this route, and loads this loads the plugin. So, detailed implementation. So, we didn't want to implement, reinvent the wheel again and again. So we wanted to use something that's already existing. And the browser already gives something, which is the script tag, which you can just add to the DOM, add the source to it, and then add loading events to it. So we can, for example, know when the code is loaded or when loading failed. And also, we don't need to re-implement the execution of it, so we don't need to use something like eval or something. So we just put it in the DOM, the stuff loads, and the browser executes it. In addition to that, we also wanted to reuse something that's already there called AMD. Someone had experience with this, know what this is? It was used in the ancient times before the agnostic modules were there. So this was basically to have a module system. It's like basically like CommonJS in Node, but older. And what's cool about this is that bundlers like Webpack or Rollup, they support this, so we don't need these plugin developers to think about how to implement AMD. They just need to write their app like normal, and then use Webpack, configure Webpack to use AMD. So yeah, how does AMD work? Anyone used Angular 1 and knows how to do dependency injection there? Yeah. So maybe this is familiar to you. So the define function is like a function in the global window scope. It has a module name, which is optional, we don't use it. Then there's an array of dependencies. In this case, it's React, Material UI, and our SDK. And a third argument, which is the callback, that is where your code is wrapped. And then this code just, instead of using React, it uses the React here. So you see it has the same amount of arguments as items in this array. And the first item in the array is mapped to this first argument. This way you can inject basically any kind of dependency. And what's really cool about this, you can just not give, they, for example, think it's React, but you modify React. So you can give them something else, it has the same interface, but do something completely different. That is also something we actually use. Yeah, and then on the plugin developer side, it is a little bit like just writing a normal React app. You have like this app, let's say just prints out hello, and what we invented was this class, which has some initialization function that's async. So this is called initially. You can load your things like translations, everything is async, and after this is finished, it will render the plugin. And then here this method called getMainComponent, which just returns this app. This might be familiar to you, because it's almost the same thing as you would do with an React app. So you have your app, and instead of putting it in the render function of React DOM, then what you do is you just return it here, and we just inject it. Yeah, and what they need to do when they finish developing or want to see the first results, and their favorite bundler, we have pre-configured Webpack, so most of our developers use Webpack, so it's easier. But any other bundler rollup also works. And you need to configure this to export AMD and define these external dependencies that React and React Router, Material UI, etc. Because you don't want to include this in your bundle, otherwise you get like a really huge bundle. And the problem is that some things don't work when you have two instances of it. React, you don't want to have two instances of it. It will not work when working with each other. Also, different versions. Then they need to upload it to their own storage because you want it to be independent. We use S3, others may use something else. And then they call our plugin registry endpoint with the URL, public URL that's behind the CDN of the bundle. After that, we know that there's a new bundle and we'll ship it in the next request to the portal. So, what actually happens when the portal is hit? So, first the plugin is requested. There's a wrapping component that handles the loading and shows a spinner as long as it's loaded. Then we inject a script DOM node. Then this script executes this define function. And we have this global define function defined globally in window. So the modules are, then we register this module after this is called. We resolve the dependencies because we now have this array. We can map it to the dependencies we know about. And then we can call this callback with these dependencies. And after that, we store this class that is instantiated, so we can reuse it. So we don't need to reinitialize everything when the user clicks back on this specific plugin afterwards. Yeah, on Webpack, this is actually really simple. It's like, this is a sample Webpack configuration. You have entry, output, etc. On the output, the only thing you need to do is the library target, setting it to AMD, and Webpack will just create an AMD file. And on the externals, you need to specify this object that actually maps your dependencies to external dependencies. In this case, we just use the names of the libraries that we wanted to externalize. And that's basically it on the bundling side. So showing this again, you see that you have this array that we need to resolve, and then call this function with these resolved dependencies. So on our side then, we have this window.define function set to our function that handles everything. And then we do something, because, I mean, this can be misused. You can just execute whatever and inject something you want to, some third party could inject something maybe. So I found this just by Googling like quite some time, but I didn't know that this actually exists. Anyone actually before knows about document.currentScript, what it does? So what it does, it returns you the script node, DOM node, of the executing script. And so this is a context dynamic. So like, depending on who's calling this code, gets a different result. And what's even cooler with in terms of the plugin system, that currentScript, because currentScript is called within our window.define, which is defined in the portal frame bundle JavaScript file. But what the plugin JavaScript file is calling is define. CurrentScript doesn't give our file, it returns the node of the plugin file. So we know who's calling this code, even though this code is not defined in this specific file. With this, you can then just compare it to the node we have registered on our side. And also what we do is compare the source of it, because in the meantime, someone could have tampered this node and can change the script file. So we also look if this is still matching the one that we have stored. Afterwards, we solve the dependencies to the array and throw something if you don't know these dependencies, and then call this callback, and then this executes the actual code of the plugin. Then we instantiate, we get this class returned, we instantiate it, save it for later use, and then render this plugin. Here you can see how resolving is done. It's really simple actually. So we have this array with these strings, and what we do is just switch case. We have like React here and return React. We just import everything from React, everything from Material UI, and everything from stock components in this example, and just return what these imports give us. The bad thing about this is it's including everything, so you can't do tree shaking. So it's bloating up the main bundle. Yeah, in addition to that, we have an SDK. So, because otherwise you can't just render something, but you don't know what you actually can interact with. And for the SDK, also you want to be agnostic, because when we use MobX on our side, and if we decide to change that, we don't want the plugin developers to know about this. So we build something really agnostic, just functions, function calls, which are not tied to any kind of technology or library, so we can internally switch. The SDK is a separate package, I'll come to this later, and it exposes functions to get data or get some helpers. So what does it expose? For example, restaurant information. What brands is the restaurant is attached to? What IDs does it have so they can do these calls? The time zone, because we have also things like in Canada you have multiple time zones. It's one of our platforms there, and you need to display these UTC times in this time zone of the restaurant. And currency is also, of course, important to render the currency from these values. Other things also like user locale to fetch the right translations, the base row to know where your entry point of your plugin is, the auth token to authenticate, also some helper functions that they can use, set the translations and translate, which uses also our translation system, so that like you don't need to redo things like okay or yes or no, because this is already done. And this is also really cool because Great API basically gives you back a wrapped version of fetch, which automatically injects the auth token in the header and handles refresh if the token is expired. So the developers don't need to care about this. It even stops all the calls, refreshes the token, and then flushes everything that was done in between. Yeah, and let's come to the actual implementation of this package, which is just TypeScript interfaces. It's like empty functions, the package itself, it does nothing, returns you empty strings or whatever. And the actual implementation lies in the portal frame. That's something I told you already before. We can basically inject whatever we like, as long as the interface is the same. So what we do here is have like a fake implementation, so the developer tooling works well with TypeScript, so they can get the right types. And during runtime, we inject a custom version of this SDK that, for example, has things like this, because this is plugin relative. Each plugin gets their own base route, so this needs to be a custom tailored SDK to the plugin. And yeah, the reimplementation is done in the frame. Here you see just like this is two functions that we expose. You just export this get base route, which in the package itself returns an empty string, and in the frame, then it returns the actual implementation of this. Also, what we have is a component library. So otherwise, you would have like plugins that design their own things, and it doesn't look like one thing. And still with the library, there's still some difference, but like at least you get like something that feels more unified. And we add more stuff to this one by one, and it also like reduces the time of development, so developers can use these graphs and don't need to re-implement the whole things. So, caveats and limitations. This is the last part of this talk. So, I already said that our main bundle is really huge. I think currently it's 600 kilobyte gzip. And the problem with this is we can't do tree shaking because this is a runtime plugin system. So we have an endpoint, we fetch these bundles on runtime, and we don't know what the plugins actually use. So you need to include all of Material UI because they might use all of Material UI. We don't know. Then this also led to some big bundles because people imported stuff like Material UI core paper, which returns you as default export the paper component. But because we have this array of dependencies, we only can give them stuff for this. Otherwise, we'd need to know all the different paths the developers might put into their import. And yeah, that's why we need to enforce this. Also, updates are harder to achieve because you have like so many external dependencies. When you, for example, update something that's breaking change, like the newest version of Material UI, you can't do it without breaking something on the plugin developer side. So you need to do something like multiple builds for different kind of iterations and make them develop the change for this until everyone is finished, and then you need to deploy this new kind of branch. And also, like, how can you solve this? So there's a thing that Netflix did, which is really cool. I saw this in the talk, which is also online at AWS reInvent in 2017. And what they did, basically first for A/B testing, they built like that they can replace certain components to just test if they work. And they didn't want to include all the experiments. So what they built is, they built their own webpack that bundles on demand. And they built like some tree, and you could like bundle these things. This is something you could do. Then you could make tree shaking, do like a service that does this on demand, but also what is bad about this, because then you are not independent anymore, because the plugin teams, they need to depend on the build environment that we have to bundle all these things together. And it is more complex, things might break. And because it's not possible to deploy the different portal versions, this is something we're currently doing. What we're doing is we're having a portal version, we deploy to a next branch, which also gives out like a next portal to go through, and there the developers can deploy separately their own bundles and fix the issues of these breaking changes. But still we need to chase the teams, so otherwise we can say, yeah, we are not displaying your plugin anymore, that's the maximum we could do. was it. Thank you. And also, we are hiring currently, so I'm also at the Rec Day in December at the Delivery Hero booth, so if you're interested, you can talk to me there.